Okay, it's the top of the hour, so I want to get started. Welcome everyone. This is the 3D modeling for 3D printing workshop. So today I wanted to go over a use of technology. I know there's been sessions on debugging, web scraping, careers in technology, and so this session is more about a use of technology. So in this case, a 3D modeling program or a CAD program, computer aided design, to do some modeling. So what we're going to eventually come out with today is this. So this is a little rubber band powered car, and shows up a little bit dark in the video, but you can see, so there's some gears here that power this key, and there's a rubber band in here that the wheels that gets wrapped around the axle for the wheels, and if I wind it up, see the key turns, and then if I let it go, the key turns, right? So the rubber band powers it forward, and it's just this simple little plastic car, 3D printed. The entire thing prints in about 2 hours, right? So very, very simple thing. But I want to go ahead and show you the design process for how you get from an idea to a physical object. So let me go ahead and share my screen, and we're going to use something called Fusion 360 for this. So Fusion 360 is a CAD program or computer aided design program. And what it allows you to do, it was a number of things. What we're going to use it for is modeling. And specifically, we're going to try to model something for the purposes of 3D printing it, right? So there's certain considerations you might take into account when you're designing for 3D printing versus, say, designing for sheet metal or designing for routing out of wood, etc. Each material has its own considerations, and each process that you use might have its own considerations. For example, there's different, even if you're 3D printing, there's different types there, right? You have your FDM, which is where you have a printer that kind of squirts plastic from layer 1 up to the top, or you might have an SLA printer, which is where there's a vat of liquid plastic that it cures one layer at a time, right? And so different considerations for different mediums. And so I'll go over some of those limitations. Specifically, this one was done with a process called FDM printing. So, and this is what the finished result is going to look like. And we're going to build it from the beginning. But, I'll tell you, I'll go through my process. I was thinking about, what should I demonstrate, and what would be a good tool to demonstrate various parts of the program with, various parts of the process with. And I had an idea for this rubber band powered car is a very kind of a common craft project. You'll find many versions of it, whether it's with popsicle sticks or whether, plastic soda bottles, etc. And since, 3D printing is a passion of mine, I decided to make a version that way. So first what we're going to do is start a new document. And in Fusion 360, everything is started from a 2D sketch, and then you make 3D geometry based on the bounds of that sketch. And so I'll show you what I mean. At the top, you have all of these different tools. The very first one is the Create Sketch tool, right? And you draw your dimensions, your lines, and then you extrude into 3D geometry. There's plenty of other tools on this bar, and we'll get to some of them. The first one I actually want to start with, if you look at the final design, is some of the main parts of this car that are going to make it work. And that's these gears. And they look very complex, and they are. Luckily, we don't need to design those at all. Well, we don't need to model them ourselves. Instead, there's a plugin I installed here called Helical Gear, right? And so the whole purpose of this plugin and it's free along with Fusion 360. So if you're wanting to design the same thing or something like it, you can search Helical Gears for Fusion 360. You'll find this plugin, you can install it. All it does is it makes helical gears, right? And why would you want to do that? Well, a helical gear, if we has its teeth that are kind of at a slant. And if you put two at a 90-degree angle to each other, the slanted teeth allows them to roll on each other and transfer the motion from this direction to this direction, right? You get the transfer motion 90 degrees. And so that's why we're using it here. And so half of 90 is 45. So we're going to make the teeth of each gear at 45 degrees. And we're going to change the module dimension so it's a little more squat and a little bit thicker, right? So I just changed this to 45. I changed this to 1. That looks like pretty good size. So I'm going to go ahead and use that. I clicked preview, so it shows me as I'm changing each parameter what's going to happen, which is very helpful. So I'm going to say, okay, I have this new helical gear in my sort of document browser over here. And one thing I like to do while I'm designing is to try to keep things neat, tidy, and named. That really helps when you're going back, and you'll see as we go. So I'm going to name this one. I'm going to call this one axle gear. Right. This is going to be the bottom gear here. And so because it's going to be that bottom gear, I want to change it so that I'm going to move it, like pressing this move copy button. And move also includes rotation. So I'm going to rotate this component. Sorry, it's not showing me the controls. It should show some controls. And so what I'm going to do is I'm going to restart the program real quick. So, little technical drama while presenting. That's okay. Get it restarted. While I'm starting that back up, I want to know, has anyone here ever done any 3D modeling before in any program, whether it's Fusion 360 or something else completely? Okay, well, if this is a new experience to any of you, hopefully this will be a good one, and you'll get, this is going to be just one idea of many that you can come up with. Last year, if you go back and you want to see what we did last year, I made a tea light candle holder. And this year we're making this rubber band powered car, right? And even if you haven't done any modeling, have you ever used a 3D printer? Even if you haven't modeled it yourself, maybe you download something from the internet, or you've just used one with a family member who knows how to use it, or even if do you even have any interest in 3D printing? Okay, so I think we're back to where we were before. And so if you haven't used one before, certainly no problem. It's easy to learn. It does take some practice. It does take some knowledge, but there's lots of places you can go on the internet and learn. And it's a great tool for making things, whether they're decorative or functional or fun. All right, so now we can see that when we select this gear, we have these controls here. I'm just going to turn this one 90 degrees this way, and so I can put my axle through it. I want one on top of it that's going to rotate and rotate our key, right? So what I'm going to do is I'm going to right click and go down to copy. I'm going to right click here and I'm going to say paste new. If I said paste, it would make a duplicate copy that if I change the original, it'll also change the copy. If I say paste new, it'll make a brand new one that's unconnected to the original, but is a duplicate of it. And you can see it put it right in the same place and saying, hey, do you want to move it around at all? And yes, we do, right? We want it to be sitting on top, just like that. And then we also want to rotate it 90 degrees. So it's sitting like that. Hit OK. Right, so there's our two gears that we'll need. And let's name this one gear. For anybody who's joined after we started, we are making this wind-up car that we have here. And if you have any questions along the way, please feel free to put them in the chat. So the next thing we need to do is we need to make a back axle and back wheels. And in order to do that, we're going to create a sketch. I mentioned that sketches are basically the foundation of doing anything. So I'm going to create a new sketch, and it's going to ask me what face, what direction, what plane do you want to put that sketch on? So I'm going to select the side of this back gear. And it's going to say, hey, some of the components that you had created have changed positions. Do you want to move them back, or do you want to capture? I'm going to say capture, because that's where I want them to be. So in this sketch, there's now new tools up here, drawing tools. You could draw lines, boxes, circles, squares, right? And so, and I didn't mean to finish the sketch. Go back into that. Okay. And so I want to draw a circle for my back axle. So I'm going to press C to draw a circle. I'm going to pick the center point in the very center of that. And I'm going to say, it's asking me how big do you want the circle? I can either drag my mouse out to select the size, or I can type a number. I'm going to just say 5. Just based on some past experience, 5 is a good size for the back axle. Right, now I'm going to hit finish sketch. And now I have a circle on this face. It doesn't do anything. It's flat. It's not really part of the model, but it's there for me to make some 3D geometry from, right? So one of the ways to do that is to use the extrude tool here. You take a sketch profile, they're called, which is this circle, and you can extrude out. And so I'm going to hit that. I'm going to select the circle. It presents me this arrow, right? And I can drag this arrow out, and now I have a cylinder from my circle. So I'm going to drag it out, say 25 millimeters. But I also want a little bit of overlap with this gear, and I'll show you why later. But for now, we're just going to say also drag inward to the halfway point. And instead of the operation being cut, let's say this is a brand new bot. And so now I have an axle. It overlaps with the gear, and it comes out here. And at the end of the axle, I need to put a wheel. So I'm going to press C to draw a circle, and I'm going to say, put it on this face, the very end of the axle. And I'm going to make this wheel, it needs to be bigger than my gears. The gears aren't hitting the ground. So I'm going to say the back wheel is 40 millimeters, right? And I'm going to say finish my sketch. And then I'm going to press E to extrude again. We're going to extrude this circle of this wheel. We're just going to extrude it right there, and we're going to let the operation join it with the axle. So now the axle and the wheel are all one body. You can see it here. I'm going to call this the back left wheel. So we're thinking of this from this direction. This is my back left wheel. You can see this. I mentioned that this is now intersecting with the back gear, right? And so one way to take a better look at that is to use the section analysis tool. Section analysis allows you to cut away for the purposes of viewing your models, right? And so it's going to say, what direction do you want to cut? I'm going to select this plane, and then where do you want the cut to be? And I'm going to pull it forward, and so it's showing our full picture here. If I zoom in a little bit, you can see that the pink shaded area is our back axle and wheel. The blue is our gear, and they are overlapping. And we don't want that. What we do want is we want the axle and the gear to fit together well, right? And so instead of trying to, I could manually cut a hole in the axle at the same size, or I can use the combine tool. And the combine tool does multiple things. One is it'll join two bodies together, and the other that we're going to use here is it will cut from this body. You use this as the tool, and it will cut away. You can kind of see the preview there. It's going to cut a hole in the gear. And we're going to select keep tool so that the tool, the wheel and the axle isn't going to go away after the operation. We're going to say, okay. Now, if you look at our analysis view, you can see these outlines no longer overlap. If I turn analysis off and hide the back left wheel, you can see we've cut a hole. Right, so now we have a smooth hole, and we'd be able to push the axle in there maybe, right? Another way that you can attach two pieces that you're 3D printing together, especially if they're round, is to create threads, right? You think of a thread like a nut and a bolt, right? So you're tightening the nut into the bolt, for example. So instead of just having it be a round hole, what we can do is we can go back, let's turn this back on, we'll turn these off for a moment, and we can create, under the create menu, a thread. We select the axle, and then we want to make sure this thread is modeled and not just kind of shown in visual here, say modeled. And then we don't want it to be the full length, we don't need it to be. We just need it to be in this case, it was a 5 millimeters that's kind of overlapping with the gear. Right, so now we have a thread. And now if we go, let's bring this back. If we go redo our combine, right, so I just move forward in the timeline after I've made my thread. And if I hide the back left wheel, we can now zoom in and see that yes, our combine, our cut, indeed also cut a thread, matching thread into the gear. In fact, it matches so much that if we turn back on our analysis, you can see there's no gap at all between these two faces, right? They're touching exactly, and that's okay if you're just modeling something. But when you think about going to actually print this out, so 3D printers are not perfect, and almost no machining process is. You need a little bit of tolerance, a little bit of gap between two parts so that they can fit together. So we're going to hide the wheel and use another tool called the push-pull tool. And this allows you to select some faces, select all the faces of this cutout here. So you see they're all blue now, and push them or pull them closer or further from where they currently are. So I found through trial and experimentation that negative 0.1 millimeters, it's a very small amount, that gives just enough gap that when you print them out, they're going to screw together nice and easy, right? And so we can now see there's a gap between all of the teeth here in these cutouts. And so that's going to allow it to attach together very easily. So I'm going to turn the analysis off. And now I want a wheel on the other side. And the wheel on the other side needs to be basically the same as the first one, right? And so I can go through that process again and create things again, or I can use the mirror tool. The mirror tool allows me to select a body and to select a plane on which to mirror, and it will create the body for me. I won't have to do it all again, but we can see that, well, I have this plane, and that is going to create another one, but it's not really in the right spot. Now they're kind of overlapping, and it's not symmetrical. So what we need is a plane we actually do want to mirror over. And so before I do the mirror, I'm going to construct rather a mid plane. I want to have the plane that's right in the middle of this gear. So to do that, I select this face, and it automatically calculates for me the center of those two faces. So I'm gonna hit OK. I'm gonna go back and mirror my wheel across that plane we just created, and now it's in the right spot. Right? So we're gonna go ahead and create a new body for our mirrored geometry here. Hit OK. And then I'm going to just hide that plane so it's not in our way. So now we have two wheels and a gear in the middle. If we look at our analysis, we can see that we've only applied that gap to the one on the right side, right? And we did this step here. This was our offset faces gap, or where we made the gap with the offset faces, right? So if we drag this mirror operation before the offset faces, well, we need the plane back there too, right? And now if we go back into our offset faces, we can edit which, sorry, right, we didn't do the combine either. We're looking at that, and it needs combined as well. So we're also going to first combine it. So let me do that real quick. Target body, tool body, and keep it. Right, so now it's properly cut out. But we want the offset faces to be last so that we can go in and edit that feature and select all the faces at the same time. You can see it's kind of an error. It's like, hey, the faces aren't what they're supposed to be here. And my program's hanging a little bit. Okay, so if we go in and we select all of the faces, and then apply. Now we just have that one offset faces operation, and the gap is across all of the teeth. Okay, and so we finished our back axle. We can see the whole thing there. Now we need some front wheels. So let's do the front wheels. So we need somewhere to draw a wheel, right? We need to draw a wheel, and we're going to extrude it from this side to that side again. So what we can do is we already know that we want the wheel to be on the same plane as this wheel. So we're going to create a new sketch on the side of this wheel, and then we're going to draw a circle. And so I just drew a circle kind of anywhere, because what I really want to do is use some dimensioning, right? So I can press D and then select some object in a sketch to set its dimension. You can see that this is showing the diameter of this circle. If I click, it's going to say, what do I want the diameter of the circle to be? In this case, I want it to be smaller than the back wheel. I'm going to say 20. I'm going to say it's half the size. So I clicked, it's 20, and it changed the size of the circle for me. And I also want to make sure that the bottom of this circle is lined up with the bottom of this circle, which will be our ground, right? So I'm going to create a line between those two and then make sure that line is horizontal. So if I press L for line, and I'm going to make this a construction line because its only purpose is to help us construct this sketch. It's not really a part of our buffer. So I'm going to click on this circle. I'm going to click on this circle. And then I want to make sure that this line, constrain this line so that it's tangent to both circles. And then I'm also going to constrain this line and say that this is a horizontal or vertical. And since it's closer to being horizontal, when I click this, it's going to snap it to the horizontal. You can see, because it was constrained to this circle to be tangent, because it's constrained to our environment to be horizontal, it brought our circle down for us. And now we know they're exactly in line with each other. But it's still able to go left and right. We didn't say how long this line away, how long this line is, how far away are these two circles from each other. So if I press D to do a distance dimension, and I click on the line here, I'm going to say that these two should be, let's say they're already close to 80 is a nice round number. Let's make them 80, and that looks like a pretty good distance. No, in fact, I'll make it just slightly longer. Let's say it's 100. Yeah, that looks about right. So now I'm going to finish my sketch. And I have a circle that's kind of out here, and that's going to be our wheel. So I'm going to E to extrude on that circle, and I'm going to drag this and say it's 5 millimeters, which is the same width as our other one. It's a new body. I'm going to say, okay. And now I need an axe to look all the way through the front. So I'm going to draw another circle in the middle of our wheel. The other axle was 5 millimeters. We'll repeat that here. I'm going to hit E to extrude that circle out. And I need it to go all the way across this time. There's nothing in the middle that we need to worry about, but I don't want to just kind of guess how far it is, or I don't want to have to measure. Instead, I'm going to make the program do it for me. So instead of it going a certain distance, I'm going to go to a certain selected object. So I hit to object. It's asking me, okay, what object do you want it to go to? In this case, I know I want it to go to the outside of this wheel. Right, so I'm going to hit the outside of that wheel there. Actually, I'm going to go to the inside of the wheel. Right, so we need to make a wheel on the end of this. I'm going to go inside of the wheel, and I'm going to allow it to join to this wheel. I'm going to say, okay. And then finally, make a wheel on the other side. So I'm going to press C to do a new circle, the end of this axle here, right in the middle. And it needs to know how big it is. I can either remember that I made the other one 20 millimeters, or what I can do is I can project some geometry that already exists in the world onto my new sketch. So I press P, short for project, and I select this circle. If I hover over it, you see it's drawn a red outline right onto my sketch. If I click it, it turns purple, and I hit OK. That geometry is now projected onto my current sketch plane, right? And so I don't need to draw anything at all. I just reference something else that was already there. And if I press E to extrude, you can see I can select that geometry just like I can select some sketch that I drew myself. In this case, I want to select, let's see, we're going to make a wheel. It's going to be both the inner and the outer parts here. I'm going to drag that out. Now that's 5 millimeters there. And I don't want to join. I want to create that wheel as its own object. The reason being, I need to be able to, I'm piecing this together, I need to be able to have the wheel on one side and put the axle all the way through the body, right? So I'm going to say, okay, that's a new body, but I need some way to connect the axle to the wheel, right? Right now, they're just kind of free floating. And so I'm actually going to use the same threading trick I used before. And so I'm going to make this axle overlap with this wheel. So I go back and I change, it's the wrong one. I go back to where we're making the axle, and instead of going to the inside, we go to the outside like I was thinking about before. And then when we extrude this one, we got to go 5 this way. We make our new body. Now we have the axle and the wheel overlapping. You can see the axle coming out here. And this is our front left wheel and our front right wheel. If I hide the right wheel for a moment, we're going to do the same thing. We're going to create a thread at the end of this axle. Make sure it's modeled, and we only need it to be 5 millimeters. It's overlapping. That's the wheel size, and hit OK. And then I'm going to bring my wheel back, combine it, do a cut again. Right? We're going to cut this body with this one. And then if I hide my front left wheel, you can see the threads there. But remember, we need to make those have enough play in them. And selecting the threads, all the faces can be tricky. So just make sure that if you're trying to select them, you can select 1, 2, and then you turn it around and select 3 and 4. Just to make sure you get all 4 faces that are making up that thread. And you can see when we make it negative, it gets just a little bigger, a little bit further away from where it currently is. We'll hit OK. And so now we have an axle, we have 4 wheels, and we'll be able to put those all together. And now we need something that's actually going to hold these wheels together. Right now they're going their separate ways. We need some sort of body. So let's go and draw that next. Go to the top and Actually, we need first draw, we need a plane that we can draw on. We don't really want to draw on this ground plane here because this is cutting through the middle of the wheels. So we're going to create a new plane right at the ground, or what is effectively our ground, right? And so we can construct a tangent plane. So we want to be tangent to this wheel. So I kind of click on the bottom there, you'll see it's picking a 0-degree rotation from that wheel. If you want to change the rotation, you can, right? If you need a different angle, but 0 degrees in the case is what we want. And now we can draw on this plane. I'm gonna make a new sketch on our ground plane. And then we need a body for the car, right? And so it's just a simple case of drawing a rectangle and making sure it encompasses the parts we need, right? The wheels are on the outside of the body, the axles are on the inside. And then we want to constrain this rectangle so that fully constraining a sketch means making sure that you define it in such a way that it's not going to move if you go back and make changes later. All right, so we're going to use the projection tool to project our wheels onto the sketch. You see now these purple lines are now part of our sketch on our sketch plane. And then we can use the dimension tool to say, okay, well, this line, let's make sure it's inside the wheel, but let's make sure it's exactly 5 millimeters inside the wheel, just as a good number. All right, we'll do the same on the other side. You can see when you do that, the lines of the rectangle turn black and you can no longer drag them around, right? The blue ones you can drag around, the black ones you can't. And so I'm going to say that, well, this can be, let's say it's 5 millimeters away from that wheel, which still captures our axle, so that's fine. And 5 millimeters away from the edge of that wheel for symmetry, right? And so that's still behind our axle and behind our gear, so we're fine. Right, now that that rectangle is fully black, it means it's fully constrained. It can't move around, and if you ever make changes to where the wheels are, how big they are, etc., it's going to automatically change that rectangle for you as well. That's the advantage of doing that. So if I finish that sketch and extrude our body, well, first of all, is because it's intersecting other geometry, it defaults to cutting that red rectangle. We don't want to cut, we want to make a brand new body. Okay, but we also don't want the body to actually drag on the ground, right? So instead of starting at the plane, we start at a little bit of an offset. And as long as our body is above our wheels and below our axle, we'll be fine. So we'll just look at it and say, well, not -10, we want 10 in the other direction. Nope, that's too high. Let's say 5. Yeah, that'll work. Right? It holds our axles, but it clears the ground. And then for the top part, let's turn our key gear on, because we know we need to go at least up to the halfway point on this part, but we don't really need to go much further. So we'll say, okay, so now we have our body, right? Well, okay. It's a very blocky car now, and none of the pieces on the inside are going to be able to turn. So what we actually want is just the shell of the body, and there is a tool for that, right? So if you have a solid object, you want to just have walls for the object, you can use the shell tool. And what it asks for is, okay, point to the face that you want to start the hollowing out process from. So I'm going to select the top, and then it asks for how thick should the walls be. You can drag this arrow. 5's a little thick. Maybe I want it to be just 2. Right? And I don't really need the bottom of the car either. So I'm going to control click the bottom. And so now it's going to shell out the top and the bottom. I'm just going to have the 4 walls around the side. And I'm going to say, okay. So now we have something where the gear inside can turn and it's holding on the axles, and this would work. But we don't really need such a boxy car. So let's make it look a little nicer and use a little less plastic. right? So we're going to create a new sketch on the face, and we're going to decide what should the profile of this car look like. And to do that, I'm going to use the line tool. And I'm just going to draw some lines and say, okay, well, we'll keep a high back, but then it goes down here, and maybe it goes across. Maybe there's a little bump up. Why not? And then we go down. And so our car will keep just kind of this bottom portion. Let's get rid of this top portion. Right, so I'm going to finish my sketch. And then I'm going to press E, select this top portion, and extrude it all the way to the other side of the car body. And we'll just cut that part out, and we'll hit OK. And now we have our car body, and it's a little sleeker, and it's used a little less plastic, take a little less time to print. And we can access the insides a little better. But if you notice, oops, I cut one of my gears too, and I didn't really want to do that. Right, so if I go back into that operation, double click down here, the very last part of this menu says objects to cut. If I expand that, it says, okay, well, body 5, that's our car body, and body 1 was our key gear, we named it, right? So if I uncheck that, you can see now it's not actually going to cut that, even though it's intersecting it. If I hit OK, now we've just cut away our car body and left our gear where it was. So great. One last thing we need on the body is a place for the rubber band to be attached to. Right? We need a fixed location for the rubber band to hold onto. If you look at our original car, I just had a little bar across the front to serve that purpose, and we can recreate that here. So I'm going to create a new sketch on the bottom of the car. I'm going to try to select the bottom of that rectangle. And I'm going to just draw a rectangle somewhere up near the front. And it doesn't need to be too big. Let's just say it's 4 millimeters. And then it touches both sides. You can see we can still move that whole rectangle around. We probably want to fix it in a location. So let's do another distance dimension. We'll do a distance to the very front of the car. And let's just say it's 15, right? Just a kind of a round number. Now you can see that's fully constrained. So if the car body size changes, so will that, right? And then let's E to extrude some geometry for it. And let's say it only needs to be like maybe 2 millimeters. Doesn't need to be very big at all. And so there we go. Now that's part of the body as well. Okay, so we're getting there. The last big piece we need to do is the key. So the key is the thing that's going to rotate, this direction when the axle is going this direction, right? And that's going to attach to the other gear. And so what we're going to do is let's call this car body. We're going to hide it so it gets out of our way for a moment. And we're going to create an axle that's coming out of the back of this gear. So do our same trick, C to draw a circle on this plane. Right in the middle, put a 5 millimeter axle. And then we'll E to extrude that axle out. And let's see our car body. It needs to come out the back of that, right? And so we want to create this. We actually want to join to this gear. This gear and this axle will end up being the same part. And I don't know, let's make it 20. That looks about right. And we're going to hit OK. Right, so now, oops, it's joined to the car body and not to the gear. That's not really what we wanted. So if you're ever joining something like this where it's intersecting two different pieces, before you click OK, if you hide the piece you don't want it to join to, and then click OK, now you can see it's joined to the key gear and not to the car body. Right. So whatever's visible when you're joining is what it'll pick something kind of randomly to join to. And one way to get around that is to just hide the part that you don't want it to join to. Okay, so we have our axle attached. Now we need a key, right? And that key part is going to be printed as a separate part. So let's model that or draw that relative to this sort of key axle. And so we need a plane to draw that on. So let's do our tangent plane again, because this is a cylinder, and draw it right on the side of this cylinder. Right, so I'll select the side, already at the right angle, hit OK, and then make a new drawing on that plane we just created. And then, so it's really just a rectangle, and let's project our cylinder into our drawing here. Sorry, but project it instead of there's specific entities. You can kind of see it's just gonna this line and this line, or there's the body. So if I select that now, you can see that it's drawing the full outline of this body. And that's nice because I actually want this top and bottom line. I'm going to reference to a distance dimension here. Just say, okay, 2.5 millimeters, that sounds about right. 2.5 millimeters, right? So now we know how big this part of the key is. And then we're going to need, so this doesn't have to be too far away. Let's just say 5, right? And then this from this, what's the full distance here? Okay, 14. Actually, let's have this, let's get rid of that one. Let's have this touch the back here, right? So let's project this as well. And then we can say the back of this is going to touch with the view, so it makes more sense. Touch this, right? Just say it's 0, but you can't say 0 when you're doing distance dimension. What you can do is say that these lines are collinear, meaning there is no distance between them. They are the same line equation, right? And so now we have that part of our key. We also need the kind of handle part. And so I'm going to make a circle out here. So, make it maybe 12, and then drag it about there is fine. I need a line. It's going to connect, something like that. Maybe my circle is a little too high. Let's make this line tangent to the circle so it doesn't cut through it. And okay, so that looks about right. And I can draw another circle on the other side the same way, or I can use the mirror tool in a sketch too, right? So if I make a line, L for line, I'm going to make it right in the center. That triangle means I'm in the midpoint. Make a line out here. And I select mirror, says, okay, what objects in the sketch do you want to mirror? I'm going to select my circle, my line, my mirror line, and it's going to mirror the same thing I have, so I don't have to worry about making it the same size or putting the same location. And then let's put one more line here on the back of these circles. Just close off the shape. And then I'm going to make sure that this line is tangent to both circles, right? So I have a fully closed shape here. One more thing I need to do is these circles need to have holes in them. So we press O to offset this circle. I'm going to offset it by maybe -2, so it's too smaller. So there's a little hole in the middle. I'm going to offset the other one to -2. And that's it. It's basically our key shape. We'll hit finish sketch. And then we're going to extrude all the parts that we want to be the key. So except for those middle circles, extrude these parts over to the other side of our key axle, right? We don't want to cut. We said this is going to be a brand new body. And okay, so we need it to be at least further than the axle, maybe 7 that way. That looks like, you know, it's enough overlap, but it's because we drew right on the very side of it, we actually want to also extend the other way And so now if we choose two sides for our direction, we get 2 arrows. I'm going to go 2 millimeters out that way, 7 this way. So there's 5 millimeters in the center that's the axle and 2 on each side. It says new body and we'll say okay. Right, so there we go. We have our key, we have our axle, and then we need some way to join them. So let's hide this. We're going to create another thread. We have been doing, select this cylinder, modeled, and starting on the wrong side, that's okay. We'll just move it over. We don't need to be 10, really, we just need to be 5. So let's move that to the very end. And then we'll hit okay. And then we'll go back. So we want to combine or cut that thread out of our key. Keep the existing component, say okay. Right, if we get rid of our, actually we'll get rid of our key gear. Let's hide the car body for a moment. We can see, look in there, there's our thread. It's going to be a little bit difficult to get to that, but we do need to make it just a tiny bit bigger. So we're going to construct inspect section analysis again. And we're just going to drag that in so we can see the inside. Our analysis was turned off. Okay, so now we can see the inside and we can select those faces and just push them just slightly back so that there's enough room when we're trying to thread these together. All right, we selected all those faces and we're going to do -0.1. Hit OK. Turn analysis back off. Turn everything back on. And now we're almost done. So the last parts we need to do are to cut some holes in the car body for these axles to actually go through. Right? If we hide everything, you can see that the car body is still solid. And so the axle is kind of interfering with it. There's no hole for it yet. So let's use our combine tool one more time and make sure that we have the right holes cut in the car body. So we're going to say, this is our target. The tools are going to be all of our axles, all the things that are going through the car body, right? Make holes into that car body with them. Say, okay. And so now we're just about done. Right, we have our car body. We have it holding everything together. We have a place for our rubber band to attach up here. And what we need is something that back here on this axle that it can wrap around. Right? It can wrap around the axle. We want something to catch it a little bit. And so I'm going to go ahead and draw on top of that axle just a little bit that we can use to catch the rubber band. So let's create a tangent plane on top of this axle and draw a rectangle. Use a center rectangle and center it right about here. We'll make it, say we make it 3 wide and 4 long. Doesn't need to be very large, just something that we can catch the rectangle with, right? And then we'll say, okay, let's make it 4 tall. So now we have a rectangle sitting right on top of the axle. And we'll be able to catch our rubber band with this, but it's kind of just sitting there. It's not attached very well, right? So what we can do is if we select this face, hit E to extrude, and we say to object, and we select the axle, you'll see it kind of wraps itself around that axle. Right? So now those two, so the bottom face is now curved with the axle. And that'll be a much better join when we actually go to print this out. But another thing to think about when printing this out is how are we going to print this piece, right? So my plan was, let's print the wheel on the bed of the printer and the axle's coming straight up out of the wheel. If we do that, the little piece we just modeled onto it is kind of hanging off in midair, right? So it's the printer's printing up this way. Then suddenly it has to print all the way out here. And this part's going to droop down and might make our print fail. Well, we don't really need this whole bit. Instead, if you know about 3D printing, one of the safe things to think about, as long as something is 45 degrees from the ground plane, like this will be enough. The print will be able, there'll be enough overlap, and it can print this shape without it falling. So I'm going to put a little chamfer there, make that 45-degree angle. And now this bit can catch a rubber band and it will be printable. I bring our car body back. I made a hole for the axle, but I didn't make a hole for this bit. So we're trying to assemble this together. That piece isn't going to fit. So what I'm going to do is I'm going to create a new sketch on the car body, project our new rubber band holder bit, select just that one face. See, it draws it there. So I'm going to hit OK. E to extrude a hole through the object to the other side. And there's our hole. I'm going to cut that and hit OK. And now one final thing I want to do to those holes is they need to leave enough room for the axles that they can freely spin. Right now, it's a very tight friction fit. I'm going to use my push-pull tool again to make the faces of those holes just a little bit wider. So select everything, all the keyhole faces here, and the front faces here. And I've been using -0.1 before. I'm going to use -0.2 now because I really want these to be kind of a loose fit. Say OK. And there we have it. We have a finished car. This car will, so you can wrap a rubber band around the front. It'll stay on this bar, and you can put on the back and then wind up the key. The key is going to turn this gear, which will turn this axle. It'll wrap a rubber band around it. And then when you put the car down on the floor or the table or whatever, you let go, the rubber band will release its energy, spin the axle back the other way, spin the key back the other way, and move forward. And that's what we have here. Are there any questions about this project, this tool, 3D printing, 3D modeling, or anything else you want to ask about? I've been chatting for a while, but feel free to pick my brain about any of this, and I'll try to answer you the best I can.
Thanks, Robert, for walking us through this. One of the questions that comes to mind for people who might be interested to pick up 3D modeling, which websites would you suggest that they can start looking into for one-on-one, right? Basics,
Yeah.
if you want to pick up 3D printing.
Yeah, great question. I mean, so I'll start with, this tool that I'm using is called Fusion 360. It's made by Autodesk. So Autodesk does have forums where you can go and get help using this tool specifically. There's, for me, I learned mostly, well, some is trial and error. I think that's a great way to learn for a lot of people. But I also, YouTube has lots of great tutorials, people making content specifically for Fusion 360, specifically for 3D printing. That's one of the ways I tend to learn things best. I'll go on YouTube and find tutorials. That's my style. So I would recommend that if it were, for me. And there's going to be plenty of great written articles out there. There's going to be books out there and full, courses. If you want to go to take a course online, you'd be able to find those as well. But for me, it was mostly YouTube videos and some trial and error.
Well, yeah, I think, as Robert mentioned, right, until you try it out, you will not know what you don't know, right? So feel free to sync up with Robert if you have any questions. He has shared with you guys on how you can reach him. Any questions? We'll wait for another couple of minutes.
Yeah, if you do, if you're trying things out on your own, feel free to, you want some advice from me, feel free to reach out to NG YWIT questions as Pooja shared earlier in the day, at netapp.com. And you can email us questions about this or your personal projects. If you're looking for some help, I can try to point you in the right direction. Thanks for putting in the chat, Pooja.
And again, all the recording will be available on the website. So if you feel that you need to go back and listen to Robert, what he was suggesting on how to do specific aspects, you will be able to, all the information will be recorded, so you'll be able to go back and review it at your pace.
Absolutely. Yep. This recording will be up on the website on the project page for this session. And we'll link all our recordings together on our YouTube channel, and all those links are going to get sent out sometime in the next 2 weeks. If there's any other questions, please feel free to leave them in the chat. Otherwise, I know there's a few minutes left, and there are other sessions starting at 2 o'clock. So if there's nothing else, I'll let you get to that.